Hello, everyone. Today we will finish the remaining of the exercises of chapter 5. And uh, last time we stopped at the question 5. A host has an IP address 172.168.131/26. Broadcast address of the subnet on which the host is located is, the answer is B. Why? Today, I will illustrate how to calculate the broadcast address of the subnet. No, this /26, that means, sorry, IPv4 address occupies 4 bytes. So the first 3 bytes is 24 bits, right? From 24 bits. But here, /26, that means the prefix have more 1 bits here. So the broadcast address is set the host portion with all 1, with 111, right? So we should transfer the first bytes 131 turned to binary notation. Binary notation is 1 50 1 1, right? So here, these 2 bits is here, right? These 2 bits. So the broadcast address should turn these 6 bits into 6 1-bit. So turn to 1061. This is a broadcast address. That means the host portion set with 111. So the last bytes will be 191. The first bytes is the first 3 bytes is 192.16.7.191. So the correct answer should be B. Now there is 2 points we should pay attention to. Decimal notation number transformed to binary form. Binary notation transferred to decimal notation. So how to transfer the decimal notation into the form of binary notation? Then I will illustrate how to transform 131 divided by 16 at 16. So here the 8, right? 8, 128, right? So it's difficult for me to write with mouse. It's difficult to write with mouse. Okay, here the remain is 3, right? So from this division, we know 131 equals 83, right? In hexadecimal notation. Right? Then 8 is then turned 8 into binary notation is 1, 0, 0, 0, right? Then turned 3 to binary notation is 0, 0, 1, 1. So 8, 3 in hexadecimal notation turned to binary is 1, 0, 0, 1, 0, 0, 1, 1. That is why here I turned this. Do you understand? Now, next I will illustrate why 1, 0, 1, 0, 1, 1, 6, 1 is 191. Now, we have several methods to realize into decimal notation. One 0, 1, 1 is 11. 0, 1, 1 is 11, right? Okay. 1, 0, 1, 1 is 11. This is not 10 decimal notation, right? Then 1, 1, 1, 1 is 1, 1, 1, 1 is fifths with 15 is 15, right? So then we can get 11 times 16 plus 15. That is 191. Okay. It is very easy, right? Okay, so question 5, answer is B. Then, next question. Question 6. The function of the application program PIN is to test the network connectivity, and the PIN is based on ICMP. Question 7. For a host with the IP address 192.55.12.116, subnet mask is 255.255.255.240. Then its host number portion is then which one is the answer? Question 7. A host with IP address, and we know the subnet mask. Then what is the host number portion? Host portion. Okay, I will illustrate how to calculate the question 7. A host with IP address and the subnet mask is 255.240. We should turn 240 into the binary notation. The binary notation is 240 divided by 16. So 116. Okay, that means 240 is F0 in hexadecimal notation, right? So that is 1111 000, right? 111100. So the host portion should located at this 4 bits, right? So we should turn 116 into the binary notation. So 116 divided by 16. right? So 116 is 74 hexadecimal notation. Hexadecimal notation, right? Hexadecimal notation. That is 7 1 0 1 1 1. This is 7, right? 4 is 0 1 0 0. This is 4, right? 4. This is 7. So from the subnet mask, we know these 4 bits is host portion. So we get these 4 bits 0 1 0 0. That is the host number portion. So 0 1 0 0, that is 4. So the answer of the answer of question 7 is A. Do you understand? Do you understand? Okay. The answer, the subnet mask is 255.240. Because the first 3 bytes is 255. That is all 1. All bits is 1, right? So we should look at the last bytes, 240. 240, that is 11110000. So we know 0 bits occupies to the host portion. So we looked at the IP address and focused on 116, turn into the binary notation 0100. That is 4. So we get the answer is A. Question 8. Generally, when do OSPF router exchange link state information? When link states change. When link states change. A. Question 9. Routing Information Protocol, RIP, is used in autonomous system. RIP routing is based on B. Distance vector routing algorithm. Distance vector routing algorithm. So this is distance vector RIP RAPE routing is based on distance vector routing. OSPF exchange link states when link states change. 10. Routing protocol message of RAPE, OSPF, and BGP are encapsulated respectively in RAPE, encapsulated in UDP, OSPF encapsulated IP. So it's not TCP. So the answer is D. BGP encapsulated TCP. So the answer is D. That is RAPE based on UDP, OSPF based on IP, BGP based on TCP. Then question 11. Which one is not a private IP address? Which one is not a private address? The answer is A. Answer is A. The 192.168 private. This is a private. This is a private prefix. Next, fill in blank questions. Fill in blank questions, I will illustrate the answer. ARP protocol maps IP address onto MAC address. IPv4 address has 32 bits. IPv6 address has 128 bits. Among special IP address, specific broadcast address in local network is 255.255. No back address is 127.0.0.1. Question 4. The router architecture can be divided into two parts, routing function and forwarding function. Question 5. The two basic technologies, the two basic techniques to implement VPN are tunneling and encryption. Question 6. An IPv6 address occupies 128 bits. It is the same as the question 2. If an IPv6 address is notated as FF01 column 0300A double column 5. Here the notation double column represents 80 zeros. Why? I will illustrate the calculation. This is the compression notation. This is 16 bits. This is 16 bits. This is 16 bits. But the total length is 128, right? So the double column treated as 128 minus 16 minus 16 minus 16. That is 80. This is question 6. It's very easy. Why the 5 occupies 16 bits? That is 5 here means 0, 0, 0, 5 by itself. This 0, these 3 zeros is not contained, is not represented by the double column here. So the 128 minus 16 times 3. Okay, do you understand? Okay, question 7. An IPv6 address occupies 128 bits. If an IPv6 address is notated as 21 double column 10, here the double column represents how many zeros? 96. Y. 128. This occupies 16. This occupies 16. So 128 minus 16 times 2, that is 96. Question 8. 2 schemes of transition from IPv4 to IPv6 includes dual protocol stack and tunneling techniques. Dual protocol stack and tunneling. This is question 8. If you have any questions, you can send a message in the discussion area. Then, if there's no questions, I will continue. Short answer questions. Okay. Short answer questions. Please briefly describe at least 3 solutions to the problem of IPv6 address shortage. IPv4 address shortage 3 solutions to the problem. At least 3 solutions. So if this question is 6 points, then each solution is 2 points, 6 points. So each one has 2 points. How to solve the problem of IPv4 address shortage? Now I will illustrate the answer. Point 1. Physical network address block can be divided into multiple subnets address block by dividing subnets. Thus, address resources can be sieved. Point 2. Using CIDR with routing aggregation can flexibly allocate address blocks on demand. Thus, it reduces the waste caused by classified addresses. Point 3. Using private addresses and NAT technology in intranet to sieve global valid address resources, or using IPv6 to provide a huge address space. So we have listed 4 scams. The question needs at least 3. We list here subnetting. The first is subnetting. The second is using CIDR. The third one is private address and NAT. The fourth is IPv6. Right? So the answer listed 4 solutions. Subnetting, CIDR, private address and network address translation, NAT. The first one, using IPv6 to provide unlimited address space. The short answer questions. Okay. Now we will turn to comprehensive application questions. Question 1. An IP address in an IP packet is captured with Wireshark. In experiment 1, we're using Wireshark to conduct the experiment and capture packets. Here, an IP packet is captured with Wireshark. The information captured is shown in this figure. 45004279, etc. Now, please answer the following questions. Please write out the hand length and the total length of the IP packet respectively. What is the protocol field in IP packet? What does it mean? What is the source IP address and destination IP address? What is the TTL checksum field? 5, last one. What is the source port and destination port? What application protocol does it mean? Notice that all IP addresses should be written in dotted decimal notation. Data field, data values should be written in decimal form. IP addresses should be written in dotted decimal notation. Please consider for a while how to solve. Then the header length and the total length. What is the header length? What is the total length? The header length. Header length. Okay, we will continue. We can fill this information into the IP packet format, into the IP packet. So we filled this date 4, 5, 0, 0, 4, 5, 0, 0, 0, 2, 7, 9, 0, 2, 7, 9, 1, CA 4, 4, 0, 0, 0, etc. We filled into the, so we filled this information into the format of IP header. Okay, then we can get the header length. We filled 5, but the header length is actually 5. Here is a 5, right? Header length is 5, but the unit is 4 bytes. So the header length is 20 bytes. 20 bytes. Okay. Then the total length. The total length is 0279. 0279 is 2 times 16 squared plus 7 times 16 plus 9, right? 0279, so here 279. So we get can get the total length of IPv4 packets 279 in hexadecimal notation actually is 633 bytes. The header length is so this is the answer of the sub-question 1. Okay, let's have a rest for 10 minutes. Let's have a rest for 10 minutes. Please consider the remaining questions. Please consider the remaining questions. Okay, let's have a rest for 10 minutes. Okay. Okay, let's continue. Just now we have talked about calculation to question 1. The head length and the total length of IP packet respectively. Some easy. Now, 2. What is the protocol field in IP packet? What does it mean? Then, in the final examination or final big assignment, I will supply appendix. In appendix, a list illustrate the Ethernet frame format, destination address, source address type, this Ethernet frame format, and IPv4 packet format, version, head length, type of service, total length. This then appendix will list these formats and protocol number and protocol number. Protocol number 1 means ICMP, protocol number 2 means IGMP, etc. Protocol 6 means TCP. Then UDP datagram format, source port, destination port, etc. Then TCP segment format, source port, destination port, etc. Then the last table illustrate protocol and well-known port number, some well-known port number. '53 corresponds to DNS. 80 corresponds HTTP protocol. 23 corresponds to Telnet. So I will supply such appendix which illustrate this packet format or some information table. Based on the appendix, I think it is very easy to illustrate, to calculate these questions. Then just now we filled the information into the IP packet, right? Now the question is, what is the protocol field? What is the protocol field in IP packet? What does it mean? The protocol field, find 06 or 06 is filled into the protocol field, right? It's a protocol field. So 6, protocol 6, what does it mean? We look up the protocol number table. 6 means TCP protocol. Protocol number 6 means TCP. So we can get the answer. The protocol field in IP packet is 6. It means transport protocol TCP is encapsulated in the IP packet. And we look at the answer. Protocol field in IP packet is 6, which means TCP is in the payload. TCP is in the payload. Right? Okay. The question 3. What is the source IP address and destination IP address? So just now we filled 0A0A015F into the source address, and DA1E737B is filled into the destination address. So the source address and destination address we can get 10.10.1.95, and destination IP address is 218.30.115.123. Okay. Zero A means 10. A, hexadecimal A means 10. 101 here means 1. 5F in hexadecimal means 95. Okay. Okay, I will illustrate why 5F means 95. Okay. So we can list A, B, C, D, E, F. A means 10, B 11, 12, 13, 14, 15. Okay, so here 5F is 5 times 16 plus 15, right? So can get here. Do you understand? Okay, now question 4. What is the TTL checksum field? What is the TTL checksum field? TTL 80. Checksum is 00. Now we look at the answer. TTL number is 128. 128. Okay, here we filled 80. Why TTL is 128? Because here 80 is with hexadecimal notation, right? So 80 is 8 times 16 plus 0. So is 128, right? Checksum field, all 0. That is 0 without dart. Now, look at the next question. What is the source port and destination port? What application protocol does it mean? Okay, we look at the answer. Here we field 5 here, right? That means the head length is 5 times 4 equals 20 bytes. The head length is 20 bytes. So 20 bytes, that means the head of IPv4 only have these 20 bytes. So there is no optional or pad, right? So because this is a 5, so the optional notation, no. Then here we field DA1E737B. DA1E737B. So the next we should fill the source port 0738, destination port 0050, right? So we should fill the source number and the destination number, right? So then we can get the source port is 0738 in hexadecimal, that is 1848. The destination port is 50 hexadecimal, that is 80 in hexadecimal notation. Then what does it mean? It means application layer protocol is HTTP, because HTTP uses the well-known port number. Why? Just now I illustrated the appendix, right? Appendix. What appendix? Just now I illustrated the appendix, the well-known port number. The well-known port number 80 means HTTP application, HTTP protocol. That means HTTP use 80, port number 80. So when we calculate and get 80, port number 80, the destination port number is 80, we can determine from the well-known port number table, and then decide application layer protocol is HTTP because HTTP uses the well-known port number 80. Do you understand? So the packet captured by Wireshark, and if we know the IP packet and TCP or UDP packet, we can fill this information into the packet header, right? So we can determine each field of IP packet. Right? Okay. Do you understand? Okay. Let's review these questions. An IP packet captured with Wireshark, right? And the information captured in the packet is listed. So we can write out the header length. 5 times 4 is 20 bytes. The total length we can also determine the value. So what is the protocol field in the IP packet? 06. That means TCP is encapsulated in the payload. What is the source IP address and destination address? Okay. Next questions. Question 2. An IP packet. Okay, question 2. Then you can finish these questions by yourself. Okay. Can you determine the value of these blanks? You can use the same method. Okay. Have you finished the filling blanks? Header length of the IP packet is here's 5. So 20 bytes. So I will illustrate the answer. Okay. I will illustrate the answer. The header length of IP packet is 20 bytes. Total length is 206 bytes. The value of the protocol field is 6. There is 06, which means the TCP protocol message is encapsulated in the data field of this packet. Then, question 3. The source IP address is it's this one. Okay. You can fill this information into the packet format. Okay. This is the appendix here. Version, header length, type of service, total length, identification, flag, offset, TTL, protocol, header checksum, etc. So we can determine each value of the fields. So we can, using the same number, using this, the method is the same as the solving question 1, right? The source IP address is 202.119 and 230.80. The application layer protocol related to this packet is most likely HTTP because the source port number of TCP segment is a well-known port number 80. Question 3. The total length of IP, it is about a segment of IP protocol. The total length of IPv4 packet is 4,300 bytes total length. We assume the total length of IPv4 packet is 4,300 bytes without option field. Without option field, the packet is fragmented. The packet is fragmented. When sent through a local area network, MTU is 100 bytes. Then we have two questions. Please determine the total number of fragments. How many fragments are the original IPv4 packets divided in two? Question 2. Please fill the data length, offset, flag bit, MF of each fragment head into the following table. The number of fragments is. Now we should grasp the method about how to solve this kind of questions. Now, I will illustrate the answer is now why the number of fragments is 3. Now I will illustrate. The original the total length of IPv4 is 4,300. So this is IP header. This is IP header. So this is a header. The header length is 20 bytes. 20 bytes. Now the length of the payload is 4,280 bytes, right? Because the total length is 4,300, right? Then MTU is 1,500. MTU 1,500 bytes, right? Then the header length is 20. So the payload of MTU is 1,480 bytes, right? So then how many how many 1,480 included in this? So we divide this value divided by 1,480, right? And 2, right? Right? So from this division, we know this is, we can get 2 times 1,480, right? And the remain 1, 3, 20, right? So we can get this segment. This segment, 3 segments. We can get 3 segments. What kind of 3 segments? Segment 1, 2, 3, right? So this 1,480 filled in the first one. The second part filled in this payload. The remain filled in the third one. So the number of fragments is 3. Right? Do you understand? Do you understand? Okay. Then the other we filled in the data length. The data length for the first is 1,480. The second is 1,480. The third one is 1,320. The offset, the first one is 0. First one, that means the beginning of the first segment is just located at the beginning of the original packet, right? This is the offset. The second is Y185. The second segment is 1,480 divided by 8. We can get 8, 6. Right? So we can get 185. The third one is 2 times 185. So the main MF, if it is not the last fragment, MF set 1. If it is the last segment, MF set 0, set with 0. Do you understand? Okay. I will illustrate this kind of questions next time. So much for today. Bye. Okay, bye.